Welcome back to the channel. This video is on environmental science and air pollution, and we're looking at wet and dry deposition. We're going to define these terms and compare the difference between wet and dry deposition, and also talk about how this relates to air pollution and the removal of pollutants from the atmosphere onto the Earth's surface. This is the Earth Science Classroom. The term deposition is defined as the removal or the transfer of material from one area to another. In this video, we're looking at the flux or the transfer or migration of material, be it a gas, an aerosol, or particulate matter, from the atmosphere and then placed and put onto the Earth's surface, be it the terrestrial surface or the aquatic or marine surface. But it's the study of movement from the atmosphere and material being removed and then deposited or placed or laid down on the surface of the Earth. The term definition can also be discussed in both negative and positive effects on the environment, and this is related to atmospheric science, climate science, looking at the biogeochemical cycles and the movement of nutrients and elements around the Earth's system, looking at pollution in the atmosphere and on the terrestrial surfaces and aquatic surfaces, and how deposition plays a major role in the flux of material from the atmosphere to the Earth's surface, which is integral to understand in both pollution and the balancing of nutrients between these two sinks, the atmosphere and the Earth's surface. The term deposition refers to the removal of gas, aerosols, and particulate matter from the atmosphere onto the Earth's surface. And there are two ways in which nature does this. There's wet deposition and dry deposition. Wet deposition is involved in removing aerosols, particulate matter, and gases through precipitation, through water, through rain droplets and cloud droplets, either in the cloud or below the cloud before it gets to the Earth's surface. So it also must include gravity in our discussion. Now, wet deposition is the most common, and around 80% of deposition on the Earth's surface is to do with wet deposition. And this occurs in two different methods. Both are called scavenging, but one is in-cloud scavenging and one is below cloud scavenging or washout. The in-cloud scavenging is called rainout, where the gases and PM and aerosols are collected within the cloud, within the rain droplet, and incorporated and dissolved into this part of the water cycle. And as gravity takes hold and the rain droplets start to fall towards the Earth, this is called in-cloud scavenging and the removal of the gases, aerosols, and particulate matter. As the rain droplets are falling towards the surface of the Earth through gravity, they are going to naturally pick up and collect more atmospheric gases, aerosols, and particulate matter in a form of removing, which is called below cloud scavenging or washout. This includes interception of those materials and the mixing of the materials and matter into the rain droplet as it falls. Now, there are a lot of different environmental factors which can dictate and control the amount of wet deposition of aerosols, gases, and particulate matter on the Earth's surface, which include the wind strength, wind direction, the concentration of water vapor and cloud formation, the climate, and the intensity of precipitation, which will have a direct effect on the volume of washout below the cloud and the mixing ratio within the cloud. Now, a very common type of wet deposition is acid rain. It's the dissolution and mixing of atmospheric gases such as sulfur dioxide and nitrogen oxides from the atmosphere into the rain droplet to lower the pH below its normal range of rainwater and become more acidic, therefore acid rain, and when it falls on the ground, we call this acid deposition. Of the two types of deposition, dry deposition does not involve water, and it is a slower and more constant mechanism that results in deposition. The percentage of deposition which is dry ranges from 0 up to 40, and in some extreme cases can be up to 60% of all deposition, but the majority is going to be wet deposition. Now, there are three main ways that particulate matter, aerosols, and gases can be removed from the atmosphere and deposited on the Earth's surface without the use or means of water. That is diffusion, gravitational settling, and impaction. Diffusion is like osmosis, moving matter from a high concentration to a low concentration. So the high concentration would be the atmosphere and naturally diffuses onto the Earth's surface where there is a lower concentration. Then we have gravitational settling, which again is in combination with diffusion, whereby based on density and size of the matter, whether it be gas, particulate matter, or aerosols, that will be deposited onto the Earth's surface through gravity. And then we have impaction. Impaction is where we have the striking of aerosols, particulate matter, and gases against the surface, and you have friction and the exchange of energy, and through impact, deposition occurs. Now, the combination of all three, diffusion, gravitational settling, and impaction, creates dry deposition. And this can be calculated through the flux formula, or the speed or rate in which deposition occurs without water, which is capital F and lowercase d, which is the amount of dry deposition, equals capital V and lowercase d, which is the deposition velocity or rate, times the capital C and lowercase a, which is the concentration of those gases, particulate matter, and aerosols. So the velocity and speed times concentration would equal the amount of dry deposition on a particular area, which is measured in grams per meter cubed. Research and development and investigations into deposition, into the flux and movement and transfer of particulate matter, gases, and aerosols from the atmosphere to the Earth's surface have greatly increased over the last few decades because of the impact this flux has on climate patterns, climate change, global energy budget, the impact and importance of the biogeochemical cycles in the movement of both nitrogen, sulfur, carbon, the water cycle. All these are integral in terms of deposition, the movement from the atmosphere back to the Earth's surface, be it terrestrial or be it a marine or aquatic surface. So looking at how much carbon, nitrogen, sulfur is transferred from the atmosphere to the ground is vitally important in terms of acid deposition, acid rain, in terms of quantifying and measuring the amount of pollutants and gases that are being transferred through either wet deposition, through precipitation, or through dry and settling and impaction. Looking at the flow of these pollutants, these gases, onto the Earth's surface, which is going to be key for any environmental scientist or pollution analysis for different areas of the world. This can affect such areas as soil quality and soil pH, ocean acidification. This can affect the terrestrial water sources in terms of lakes and ponds and rivers, in terms of acid deposition, the effect on vegetation, the effect on growth of biomass, and the effect of these biogeochemical cycles being interrupted, being impacted by these additional gases and particulate matter and aerosols being transferred and deposited onto the Earth's surface. So therefore, the studying and understanding of wet and dry deposition is very important. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.